Hello boys and girls and Cougar parents. Today we're going to take a look at another application of the Pythagorean theorem. This time we're going to be looking at the coordinate plane and we're going to be looking at 2 points with a line that connects those 2 points. We're going to be finding the distance between those points, and you guessed it, Pythagorean theorem is going to be very useful in finding the distance between those 2 points. Let's take a look at some sample problems now. Okay, boys and girls, let's find the distance between these 2 points. Now, with these 2 points, we need to, first of all, we need to graph paper and we need to plot these 2 points given the coordinates that we have here. And we first have, the first 2 coordinates are 5, 4, so I go 5 to the right, 4 up, which would be right there. And then my second point, again, that is 5, 4. My second point is 2, 3, so I go 2 to the right and then 3 up. And there I have 2, 3. So there's my 2 coordinates, and I want to find the distance between these 2 points. And the way I'm going to do that, well, let me tell you one thing I'm not going to do. I'm not going to count this block and say it's approximately 3. Okay, the number one wrong way that students try to solve this is they count how many, they count diagonally with the blocks. And watch what happens. I'm just going to prove that that will always give you the wrong answer. Okay, if I were to count and say, hey, that diagonal is 1 unit wide, you're wrong. You're wrong. When I say, well, it looks like it's 1, well, don't go by what it looks. Watch what happens. When I drop a line there and a horizontal line there and make a right triangle. Okay, let's look at this triangle. What is the height of the triangle? Well, it's 1. What is the base of the triangle? It is also 1. What is the hypotenuse? Well, I know for a fact, it's a rule, mathematical rule, that the hypotenuse, okay, that's the side opposite of the right angle, is always the longest side of the triangle, so it's got to be longer than 1. Boys and girls, when you count diagonally, okay, when you count diagonally the squares, you'll get the answer wrong every time. Okay, if you're going to count the squares, you can count vertically up and down and horizontally sideways, but you cannot go diagonally. You will get the wrong answer every time. So please, this is how you do it. You need to use your Pythagorean theorem. The first thing you do is you drop a perpendicular line and a horizontal line to create a right triangle. Okay, now once I have the right triangle, I say, well, right triangles, using the Pythagorean theorem with a right triangle, I need to know at least 2 sides, and they didn't give me any sides. Well, yeah, they did. Now we can count. Let's count. The base would be 3. The height would be 1. Okay, we can use the Pythagorean theorem now. So we're going to say a squared plus b squared is equal to c squared. A is 1. Okay, the base would be 3. And side c is what's unknown. So I get 1 plus 9 is equal to c squared, or in other words, 10 is equal to c squared. And I want to find c, not c squared. So I need to ask myself, what's the inverse of squaring something? It's finding the square root. And what I do to one side, I do to the other. Now I know that the square root of 10 is between the perfect squares of 9 and 16. The square root of 9 would be 3. The square root of 16 is 4. I need to slow down. Okay, so the answer is somewhere between 3 and 4. 3 is too low, 4 is too high. So how do I find the in-between? Well, the fractional part of this answer we find by taking the difference between our 2 perfect squares. The difference between 9 and 16 is 7. Okay, and then my numerator would be, what's the difference between my first perfect square and the number that I'm trying to find the square root of? And the difference between these two is 1. So my exact answer to this problem, the square root of 10, is 3 and 1/7. But if you look in the directions, it asks for an approximation to the nearest tenth. So I need to take this one step further, and I need to take this fraction and turn it into a decimal. Now, we know that every fraction is a division problem, so 1/7 is really 1 divided by 7. Okay, so I need to take 1 and divide it by 7. Okay, 7 goes into 10 one time. Get 3's remainder. Bring a 0 down. 7 goes into 30 3 times. Sorry, 4 times. Yeah. 4 times. 4 times 7 is 28. Doesn't really matter if it's 3 or 4. in this case because we're rounding to the nearest tenth, and 1300ths would round to just 1/10. So my answer to the nearest tenth would be 3 1/10. Let's take a look at number 7. Here we have 2 more points, and then we have the coordinates for each. Our first point that we need to plot is 6. So we go 6 to the right, and then -3 means 3 down. Okay, and then our next point is 1 to the right and 4 up, which would be right there. There's our 2 points. If we drop, now we connect the 2 points. There's our straight line, and let's change the color up just a little bit here. Okay, and we need to, if we want to find the distance between these 2 points, we already know we don't want to count blocks. We'll get the wrong answer every time. We're going to drop a perpendicular line right there, and then bring a horizontal one across there. Okay, and we now have a right triangle, and we know that the height is 4 above and 3 below, so that would give us a height of 7. And the base, the width of the base, well, we're going from 1 to 6, which the difference would be 5. Okay, so we use a squared plus b squared is equal to c squared, this being side C, the hypotenuse, which is always across from a right angle. A would be 7, b would be 5, and c is still unknown. 7 times 7 is 49. 5 times 5 is 25, which is equal to c squared. 49 plus 25, that's going to be 60. 74 is equal to c squared. I want to find the square root of both of these. C is equal to, well, I know that the square root of 74 is somewhere between the perfect square of 64 and 81, okay, which is somewhere between 8 and 9. And to find my fractional part, to get a little more exact, the distance between, or I should say the gap or the span between 64 and 81, that would be 6, 17, yeah, that would be 17. Okay, because that. And then the distance between these two is 10. 64 taken away from 74 is 10. So that's my exact answer. And if I want to get it into decimal format, I would have to take 10, divide it by 17, make that 100. 17 goes into 100. I'm going to say 5 times. 5 times 7 is 35. Carry the 3. 5 times 1 is 5 plus 3 is 80. That's 8, 85. I subtract, I'm going to get a difference of 15. I bring a 0 down. 17 is going to go into 150. Oh, it's going to be close to 9 times almost. 8 times. Okay. Doesn't really matter because I know that this 0.5 is going to round up. That'll be 80. That'll be 56. And actually might be 9 times. No, it won't be 9 times, it'll be 8. So 8 times 7, 56, carry the 5. 8 times 1 is 8 plus 3, 13. Group, we get 4, 1, remainder 14. I can stop right there. And this is going to round, this would round up to 0.6. So my answer would be 8.6 approximately for side C. Okay, let's take a look at numbers 1 and 2. Simple enough. Okay, number 1, we've got a diagonal line here, and we need to find the distance between these 2 points. The first thing we're going to do is drop a perpendicular line from there, and then a horizontal line connecting those two. Okay, I've got a right triangle, and the height of this right triangle is 1 2, 3, 4. It's 4 high. And the base would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the base is 10. I'm going to use a squared plus b squared is equal to c squared. A would be 4, b is 10, and c is still unknown. So I have 16 plus 100 is equal to c squared. I have 116 is equal to c squared. I need to find the square root of c, which is, the square root of c squared, which is c. And the square root of 116 is going to be somewhere between, hold on here. Okay. The square root of 16 is going to be somewhere between the perfect square of 100, which is 10, and 121, which is 11. Okay, so it's going to be 10 point something, and my point something I'm going to derive from finding the distance between these two perfect squares, which is 21, and these two square roots, which the difference between the square root of 116 and 100 is 16. Okay, so that is my exact answer, 10 and 16/21. But I need to change it to a decimal. I have to find my answer to the nearest tenth. So I take 16 divided by 21. 21 goes into 160. I want to say 7 times. 7 times 1 is 7. 7 times 2 is 14. I subtract, and I'm going to get 13. And then I bring down a 0, and 21 would go into 131, I believe, 6 times. 6 times 1 is 6. 6 times 2 is 12. I get a remainder of 4, and I can stop right there. My answer is 0.76. So if I was going to round this, this would be 10.8. Okay, so this side here is approximately 10.8. Now let's take a look at number 2 over here. Same thing. First thing I want to do is drop my perpendicular line. If I want to find this diagonal line, I need to treat it like a hypotenuse to a right triangle. Okay, and so I need to drop a perpendicular line and a horizontal line to create a right triangle. The height is 1, and the base would be 1, 2, 3, 4, 5, 6. So, again, a squared, let's change the color so we don't, okay, a squared plus b squared is equal to c squared. A would be 1, b would be 6, c is unknown, so I got 1 plus 36 is equal to c squared, which is the same thing as 37 is equal to c squared. I want to know what c is, so I need to do the inverse operation of squaring something, which is the square root. I do that to both sides. And c is going to equal the square root of 37, which is between the perfect square roots of 36 and 49, which means it's going to be, oh, did it again, got my, and 7. Okay. So my 6 point something is going to be, again, I get the denominator by finding the difference between 36 and 49, which will be 13. And then the difference between 36 and 37 is 1. So the exact answer is 6 and 1/13, but I need to change it to a decimal. So I take 1 and I divide it by 13. 13 goes into 10 0 times. 13 goes into 100. Let me see, 5. I believe 7 times. No, it's going to be, yeah, 7 times. 7 times 3 is 21. 7 times 1 is 7, plus the 2 is 9. I subtract, and I get 9 as a remainder. And I can stop right there because this would round. This would round up to 1/10. So my answer is 6 1/10. So side C is approximately 6.1 units, whatever that is, whatever those units are. Yes, I'm back, and I hope it was helpful. And as always, if you have any questions, please, please, please bring them to school tomorrow, and I'll address all of those questions. Have a great evening. Bye-bye.